Okay, so you can also use these factors to write out, or these prime numbers, the prime factorizations, to write out all the possible factors of 150. Okay, so before I show you how to do that, I want you to write every number that divides into 150. Okay? So that starts with 1, right? What else divides into 150? We'll keep a little collection over here and see if you can get them all. What else goes into 150? Yeah, why don't you tell me? Yeah. 2 goes into 150. And I'm actually going to put them down as pairs. So 1 goes into 150 and 150 goes into 150, right? 2 goes into 150 and 75 goes into 150. What else goes into 150? Just 3? Yeah, 3 goes in with 50, right? How about 4? No. And how do you know? Look at the last 2 digits, right? So 4 doesn't go in. How about 5? Yeah, 5 goes in with 30. You're right. Okay, 6. Yeah, because we know 2 goes in and we know that 3 goes in. So 6 has got to go in. So what would that be when 6 goes in? 25? Okay. 7? No. 8? No. 9? No. 10? Yes. And 10 goes in with 15, right? There's only actually 4 other numbers to possibly check, because then we'll start back down this row here. The only other numbers that could possibly go in here would be 11, 12, 13, 14. What do you think for those? 11, no. 12, we'd have to have 3 and 4 in there, right? So that doesn't work. 13 is a prime, and it would be 130 plus enough 13, so that can't possibly work. 14 would actually have to have 2 and 7 in there, and 7's not in there. Okay? So those are all the factors of 150. Okay, that's a little bit tedious to go through that. I'm not sure that this other process isn't just as tedious, but as the numbers get really, really big, this process is going to be a little easier. Okay? So the other way you could write down all the factors is to look at every number in here and look at every power of those numbers in combination with each other. This kind of sounds bad, but it's not as bad as it looks. So we start with, like, we say, all right, 2 has to be in there. And this is 2 to the first power. This is 3 to the first power, right? So when I look at factors of 150, I could have 2 to the 0 or 2 to the first. I could have 3 to the 0 or 3 to the first. I could have 5 to the 0, 5 to the first, or 5 to the second. Why did I go up higher on the 5? Because it has a second power in there. Okay. Then the other trick here is that you've got to use any combination of those numbers. Okay. So you could say, okay, well, 2 times 3 would have to be in there. Also, 2 times 5 would have to be in there. And 2 times 5 squared would have to be in there. Okay, so we're kind of going at this systematically. Then we'd have to look at 3. So we'd have to say, well, 3 times 5 would have to be in there. And 3 times 5 squared would have to be in there. And there's 2 more missing. Let's see what they are. Well, 1 is in here multiple times because of all these zeros, right? What am I missing that has to still be in here? 5 times 5 is there. It's right there. So I did 2 times 3, 2 times 5, 3 times 5, 2 times 3 times 5 is the one I'm missing. All 3 numbers together, okay? So I'd have to have 2 times 3 times 5 and 2 times 3 times 5 squared. That gives you a list of all the factors. So it's every number in combination with every other number. I'm not sure that's easier than doing this. This is fairly easy. But if you had like a 7-digit number you had to do, and you knew this prime factorization, you can crank out what the numbers are pretty easily with that, compared to this method, which might take you a long time, depending on what you're looking at. Now you do take repeats off this list. So if you see something in here twice, like what is 2 to the 0 really? 1. And 3 to the 0 is also 1, so I'm just going to take that off. And so is 5 to the 0. So those are all repeats. The rest of those I think are unique numbers, and they should be the same ones off this list. Okay? All right, so that's how we can write out the factors for a number. And so when I write out all these factors, we can do this for two numbers and find what's called the greatest common factor. That's just the one they have in common. So we're going to do a few examples. And let me find my list of examples. Let me first give you a definition of the greatest common factor. So the greatest common factor for two numbers is the largest of the factors that they have in common. So we're going to start easy here, okay? So, and we use this notation for it when we want to say the greatest common factor. We say GCF of, and we put the two numbers like this, and then the answer for it there. Okay. So we're going to start by finding the GCF of 12 and 20. Okay. So what we're going to do is list factors of 12. And we're going to list factors of 20. Okay. So factors of 12, starting at the bottom, would be 1. What else? 2. Before 4. 3. 4, 6, 12. There we go. Okay. 20 would be 1, 2, 4, 5, 10, and 20. So we look for the greatest number that they have in common as factors, and so in this case that would be 4. So we would say that the greatest common factor of 12 and 20 is 4. Okay? So I'm going to show you, well, let's do one more, and then I'm going to show you a different way to look at this. Two different ways to look at this. So let's also do 12 and 72. So we're going to find the GCF of 12 and 72. So we already had the factors of 12. That was 1, 2, 3, 4, 6, and 12. Right? Now we'll do 72. And maybe we got to do this as a set of pairs here. So 1 with 72, 2 with 36, 3. You know what that one is? It's 24. Okay. Does 4 go in? Yes, so 4 with you can always do the division off to the side, right? 72 divided by 4 is, that would be going once, subtract, that would be 32, so that would be 18. Does 5 go in? No. Does 6 go in? Yes. How do you know? 2 and 3 go in, right? So 6 has to go in. Also, we know it's 6 times 12, right, from our multiplication tables. 7, no, 8, yeah, it's 8 and 9, so then we're back down to the bottom row, okay? So what is the greatest common factor that goes into both of these here? 4? 12. So the greatest common factor is 12, right? Okay, so this greatest common factor is something we use a lot, especially as we get into algebra and we do things like factoring, right? When we look at two numbers, like we might look at an expression like this, 12x plus 72 y, and we look for the greatest common factor to take out of that, right? Which is 12, and so we would write that as x plus 6y, right? So this is something that we build on later on in math quite a bit. So let me show you two other ways to look at these greatest common factors to find them. Okay, so I'm going to stop this and switch over to